Let's suppose you have one network here, switch, and then you have some PC, right? Then you have one another network, same like this. Here you are using one network 10.1.1.0/24 network. Here 10.1.1.1.2.0/24. Don't worry about this network ID, we'll discuss later. So if you want to connect these two network together, I need to connect with router, right? So again, router will have what? NIC. So through the NIC, I can connect this switch and this switch. Again, this NIC will have one port ID that can be 0/0 or 0/1. Correct. Now, how this router is going to forward traffic from this user to this user? How? First of all, see guys, tell me, router have identity till now? No. We didn't configure any IP address on router. So actually switch don't know router till now. There is no any connectivity between router and switch till now. Even your port is by default shut down. Port of switches are by default up, right? We are not running command no shutdown. By default all ports of switches are up. But if I will talk about the router interfaces guys, so by default router ports are down. So first thing, I need to configure this router. Like you can use switch without doing any configuration, just purchase from the market and after that you can connect multiple devices. They can communicate with each other. But this is not the case with router guys. If you have router, first you have to configure the router. So in the real-time production, you will have warehouse. In the warehouse, you will have lots of devices. Maybe you will configure devices there, and after that, you will send it to site. Or maybe in data center, you are going to replace one device. So first, you will configure that device. After that, you will insert that device in rack. Okay. So see guys, what configuration are required. First thing, first of all, we need to up these two ports because now I am going to use this port and this port of router. So these are down by default. First of all, we need to up the port. So we will run command no shutdown on their interface. No shutdown. Once I will hit enter, router will get to know, okay, someone is telling to up the port. So router will up the port, both port. After that guys, you need to configure one IP address, right, on both interface, right? So that will be identity of device, NIC, where address is hard coded, and you are going to configure one more address, that is logical address. So with the help of that address, these devices can communicate with router. See, if these device want to communicate with these device, first these devices need to communicate with switch, then to router. So router need IP address, and router need IP address on their both interface, on this interface also and on this interface also. Through this interface 0/0, this router can communicate with these user, and through this interface router can communicate with these user. Right, so let me configure one IP here that is from the same network guys, from this network. Let's say 10.1.1.254 or 1.1.100, and here IP address is 10.1. Let me correct it. Here I am using, let's say, different subnet 20 network 20.1.1.0/24. So here IP address is going to be 20.1.1.0 1.254/24. 254/24. You know what you did guys on router? First you have up the port, then you have configured the IP address. See, once you will configure IP on router interface, router is going to maintain that address in their table. Which table? Routing table. Once I will configure this IP address on their interface, router is going to start maintaining a table called routing table, and it will make one entry in their routing table. It will make one entry in their table that on my 0/0 interface, someone have configured this IP address. That means I am a part of 10.1.1.0/24 network. It will find the network ID of that IP address. You will learn how we will find network ID from IP address in the subnetting. So this router is going to find network ID, and after that it will make one entry that on my 0/0 interface a network is connected. That network is 10.1.1.0/24. Then you will configure IP on this interface also. Again, router is going to make entry that on my 0/1 interface a network is connected. That is 20.1.1.0/24. Done. Now router is not going to run any timer over here. These entry are permanent. Still, these ports are up. Until unless these ports are up, entry will be there guys in routing table. If you will remove the IP, automatically entry will remove from here. If you will shut down the port, IP will be there, but that interface will be considered as unassigned. Means you cannot forward the traffic from there, but entry still will be there in the routing table. Done. Now, just suppose router is receiving a traffic. Router is receiving, let's say this router is connected with any other router, or let's say with internet suppose. And if this router is receiving a traffic where destination IP address is, let's say source IP address is anything X. Destination IP is 10.1.1. Let's say 10. What this router will do? This router will receive this packet and it will check destination IP address. It will check destination IP address. Destination IP address is 10.1.1.10. Again, router is going to compare this IP address with their routing table. Means what? Do I have any interface for this network? So network ID of this IP address is by the way 10.1.1.0/24. So router is going to look up their routing table. Is there any interface available for this network? So tell me guys, interfaces are available or not? Is available or not? Yes. Network ID is 10.1.1.0/24. 10 network 10.1.1.0/24 network is connected on 0/1 interface. So blindly router is going to forward this packet from their 0/0 interface. This is how router is going to forward traffic. Clear to all? Is it clear guys? Different network. See, right. Okay. Now let's say this PC IP address is 10.1.1.1. This PC IP address is 20.1.1.1. 10.1 want to communicate with 20.1. Source IP address is going to be what? 10.1.1.1. Destination IP 20.1.1.1. Right? PC will forward it to switch. Switch will forward it to router. Router will receive it on which interface? 0/0 interface. What router will do? Router will check destination IP. Destination IP is 20.1.1.1, and this IP address is matching in this network 20.1.1.0/24. Right? So router is going to compare destination IP address with their routing table. If route is available in the routing table, then only router is going to accept it. Otherwise, router will discard it. But see, 20 network is available in the routing table, and exit interface for 20 network is 0/1. So router is going to receive it on this interface and it will forward it from this interface. So every time whenever router is going to receive traffic packet, it will check destination and it will compare the destination with routing table. If route is available in the routing table, then only it will forward traffic, otherwise it will drop it. Is this clear to all? Okay. So see guys, let's say I have a network like this, router 1, router 2, right? And here I have one network, here I have one network 10.1.1.0/24 and here 20.1.1.0/24. Again, network means here we have one switch and then switch is connected with lots of end devices, means PCs. So I'm running this network over here, this network over here, and I need to run one more network between routers so that router can communicate with each other. See, till now router 1 and router 2 cannot communicate with each other because we don't have any identity on this link. So let's say here IP address is 12.1, here IP address is 12.2. So guys, in the routing table of router 1, how many network will be there by default? 2 only, right? One is 12 and one is 10, correct? In the routing table of router 2, how many network will be there? Again, 2 only, 12 and 20. So can 10 network communicate with 20 network? Never, right? Because what will happen when 10 want to communicate with 20? It will forward traffic to router. Router will compare destination IP address, means destination network is this one. It will compare it with routing table. Route is not available. In the routing table, only 12 and 10 network is there. Yes or no? So here we need to configure routing. We will see later. Okay. So first of all, tell me networking devices is clear, guys. Basic networking devices, router, switch, hub, these NIC, these are to all. I have one more device, that is firewall. So now guys, see, I have this network switch, then I have lots of PCs here. Network is 10.1.1.0/24 is connected with one router and this router is connected with internet. Guys, we have placed a router over here just to make communication possible between internal network to external network, right? To connect two different network together, I am using router here, right? This is the actual work of router. Why I am using switch over here? To connect multiple devices together, right? Multiple computers together, correct? So like this user can access internet, no problem. But is these users are secure, guys? Because internet is public network, lots of bad people are also there. So if anyone from the internet will try to ping this IP address, this PC, they can ping. Let's say here you have one server, right? Web server, lots of your employees are very critical servers. You have multiple backup server as well. And what if someone will send some virus that will corrupt your server from the internet? So security is also important, yes or no? Because this network is completely unsecure. Anyone can perform attack. Anyone know your IP address, they can perform the attack. So as public network is not secure, private network is very secure. So I will not allow traffic from public network to private network directly. First, I will put a device who is going to check the traffic. If traffic is genuine, then only I will allow it. Otherwise, I will discard it. Before the router. Before the router, if I will put one device over here, now whatever traffic this device is going to receive from internet, not from internal interface for now. Just suppose whatever traffic it is receiving from internet, it is asking, who are you? Why are you going to inside? And after that it will decide whether I should allow it or not. So we need a device, this device over here or not, guys? Yes, we need it. But right now I am using switch for connecting multiple devices only. You don't know, I didn't teach you any security feature on switch till now. Yes or no? That is secondary thing. How I can use switch, how I can configure some feature on router to secure. We'll see those all. For now, main purpose of switch is switching. Main purpose of router is routing. And main purpose of security is firewall. Right? So that's why. Hmm. Yes, we can configure ACL over here, even we can create policies over here, but not like firewall. NAT is just a translation, brother. Means your private IP address is hidden, right? Means your private IP address is accessible from public IP address. Let's say there is someone who have hide your IP address, and instead of that, it have given you a new IP address. Let's say 1.1.1.1, and your server IP address is 10.1.1.1. So this is security, guys. Is it sufficient that I have convert this IP address into this IP address? Yes, it is also security, but this is not sufficient. Earlier I was pinging to this IP address, now I will ping to this IP address. Earlier I was sending virus to this IP address, now I will send to this IP address. NAT is giving you the security, it is just hiding your private IP address. Otherwise, NAT is responsible for translation. NAT is not security feature or concept. NAT is a technology which is used to make communication possible between private network and public network. Because by default, the private and public cannot communicate with each other. Even private IP addresses are not routable on internet. You can't reach to internet with the help of your private IP address. Now, if you are thinking my machine is still using private IP address and I am able to access internet, like right now my PC is using private IP address. Private IP, yes or no? This is private IP. But I am able to access internet. I'm able to ping Google. So why, guys? Because my router is doing translation. Every time when my router is receiving my traffic, it is translating source address. It will set their own source address. And when it will get reply message, then again he is going to translate it to the original IP address. Do you want to see my public IP address? Miss, my router is translating my private IP address into which IP address, which public IP address. Simply on the Google, you can type what is my public IP address. What is my IP address? It will show me IPv4 as well as IPv6 address. Yeah, multiple sites are there. So you can check your public IP address. You are reaching to internet through that public IP address. So actually NAT is doing translation. NAT is not running to secure your network. Okay, but firewall will be working to secure your network only. Got it? So you cannot say that I will not use firewall because I have NAT. Firewall is providing many more features. When we will discuss the firewall, you will see the configuration and how we can achieve, you know, good security. Means completely we can secure the network. Even you will not configure the firewall, then also firewall is going to provide you security without doing any configuration. Just configure the interfaces. Once you will place the firewall and you will configure the interface, now this firewall will not allow traffic from internet to private network, public to public to private. It will drop all the traffic. Whatever traffic you will send to internet, this device is going to maintain a table. That table is called connection table. It will make one entry that this user is going to internet, so I will allow him to come back. Means reply is allow. If you are sending request to the internet, then your reply is allowed by default by the firewall. But if someone is sending traffic from the internet, then traffic is denied, drop. This is why, because guys, suppose this is my firewall ASA, and this interface is connected with internal router R1, and this interface is connected with internet, right? So you will configure this interface as outside interface, and this side interface as a inside interface. Means this is your inside interface, right? We'll see these all configuration. Also we'll configure this interface as inside interface. Firewall will get to know that this port is the trusted port, the port where I can trust, right? Also we'll configure this port as outside. This firewall will get to know, no, this port is untrusted port, and it will set security level 0 over here. It will set security level 100 over here. Security level is nothing but, you can say, trustworthiness of interface. Okay, ASA is a firewall, like Palo Alto firewall, Checkpoint firewall, router, switches. Like we have switch, we have router, we have another device, that is firewall. Palo Alto is different company, na? ASA is the firewall of Cisco. Like now you are learning Cisco router, you are learning Cisco switches, you are learning Cisco firewall. Got it? CCNA and CCNP means Cisco Certified Network Associate, Cisco Certified Network Professional. You are learning about Cisco. So ASA is Cisco firewall. Okay. So now guys, just see. Yeah. Yes, yes. F5 is a load balancer, brother. Load balancer. Okay. So on the inside interface, guys, ASA is going to allow traffic. On the outside interface, ASA is going to not allow the traffic. So see, the basic function of firewall is by default behavior, higher security level to higher security level to lower security level. Traffics are allowed, right? And second behavior, lower security level to higher security level. Traffics are not allowed. Getting my point? So can guys, here I have one PC. Can this PC ping to internet? Can access internet? Yes. Can internet access this PC? No. Because lower security level to higher security level traffic are not allowed. higher security level to lower security level traffic are allowed. Now, if you are thinking when internet will generate reply, then how ASA firewall is going to allow lower security level to higher security level traffic? So as I told you, ASA will maintain one table that is called connection table. Whenever it will receive a traffic over here and it is forwarding from this interface, it will maintain it in table, in the connection table. So according to that table, it will allow the reply message. Okay. So every time whenever it will receive traffic on outside interface, first it will check this table, connection table. If entry is there in the connection table, then only it will allow traffic. Otherwise, it ASA will discard it. So till now we understood the basic function of switch, and before switch hub, then switch, then router, and then firewall. Guys, hub is a dummy device, so we are not going to talk about hub. No memory, no operating system, nothing. Always do broadcast. Now switch. Switch is a layer 2 device which is used to connect multiple end devices together. Switch maintain MAC address table to forward traffic. Whenever switch receive traffic on their interface, it learns source MAC address, and on the basis of destination MAC address, forwarding switch takes forwarding decision. Now router is a layer 3 device which maintain routing table to forward traffic. Whenever you are configuring IP on router interface, it will make one entry in the routing table that on my particular interface, particular network is running. Then firewall. Firewall is a security device which maintain connection table to forward traffic. By default, inside to outside traffic are allowed, outside to inside traffic are not allowed. Is it clear guys to all? Okay, let me. Yeah, router is a layer 3 device. And firewall, you tell me. Few people are saying it is a layer 3, layer 4, and layer 5 device. Few are saying layer 4 device. Few are saying layer 7 device. But firewall is the device which works from layer 1 to layer 7. Firewall works at all layers. We will see when I will discuss firewall. Okay, so it works on all layer. Now next topic is cabling. So before discussing the cabling, we'll discuss Ethernet. So what is Ethernet guys? How many of you know about Ethernet? Let me check. Yes, what is Ethernet? Is it a device? No guys, it is not a device. I'm talking about protocol this time, or about the technology this time. Now you are going to learn how to connect these devices, right? Guys, remember in day one we discussed basic things like types of communication, modes of communication, right? And some basic fundamental of networking, how network look like of a small office. Then we talked about the devices. Now we are going to learn how to connect these devices together. Fine. Then we will understand how we will do the addressing. Getting my point? So Ethernet is something related to connecting devices together. So tell me if anyone knows anything guys about Ethernet. No one? Anything guys? No? Layer 2? Layer 2 connectivity. No, no, even we can connect to router as well. Okay, Ethernet is a technology, guys. Very popular technology for LAN communication nowadays. For LAN communication, Ethernet is a very popular technology nowadays. Is it visible? Can anyone read what is Ethernet? Ethernet is a technology used for connecting computers and devices in a local area network. Like multiple computers are connected with a switch, and that switch is connected with another switch. Again, on the another switch, we have lots of end devices, PCs, servers, IP phones, printers. It allows devices to communicate with each other using common network protocol. Think Ethernet as the set of rule that tells how data is transmitted over network. Think Ethernet like this. Oh, real time use. In everyday life, we all are using Ethernet. Ethernet is used in various scenarios. Tell me, guys, where you are using Ethernet right now in your home, where you are using Ethernet in your home. Yeah, in the smart TV connectivity as well. Yes, Wi-Fi. Everyone have Wi-Fi connection at home, broadband. Yes, you all are using even fiber cable, I think. So fiber cable as well. Virtually, no, physically, physically. For we'll discuss about the wireless later. That is wireless, not like virtual. Wo- Wireless connectivity between two devices, na? Yeah, yeah. So guys, we are using it in home network. Gamers are, connecting multiple devices together through Ethernet, or even you can connect two computer together through Ethernet cable. So I have lots of Ethernet cable in my home. Okay, so like my Wi-Fi router is connected with my, another PC with Ethernet cable directly to get better speed. Then we are using it in office networks. Like in office, you have multiple devices and you need to connect them together. So you can use a hub or switch, and after that Ethernet cable. If you have a printer, photo Xerox shops, these guys are using it. Then in the data center and big enterprises company. Why in the data center? Ethernet is crucial in data center, connecting thousands of servers and storage devices for efficient data processing and storage. So guys, see, thousand number of servers in one data center, right? So here in the simulation software, guys, or in CCNA, we always draw diagram like this. That switch connected with few computers, four computers. But in the real time, all ports will be occupied on switch. Guys, even this switch will be in a stack, means multiple switches will be there. On a single switch, you will have lots of ports. Okay. So we are using it in data center and enterprises company, guys. Then industrial automation. After that, types of Ethernet. How many types of Ethernet we have? And guys, how we divide Ethernet? On the basis of speed and capabilities. How we divide Ethernet? On the basis of speed and capability. Even distance, you can say speed and distance, or any other properties. Then these all types are categorized into again two parts. So types of Ethernet. First is fast Ethernet that you are using in packet tracer right now. First type of Ethernet cable is fast Ethernet, and before fast Ethernet we have Ethernet as well, right? But nowadays we are not using it mostly, generally. So connect these two devices together. I need a Ethernet cable here, right? And my cable can be fast Ethernet. My cable can be Ethernet. If I am using Ethernet cable, then I will get 10 Mbps speed, 10 Mbps bandwidth. Then we have fast Ethernet with 100 Mbps bandwidth, an older standard but still in use for less demanding applications. Like say, let's say you have very less number of traffic on a specific server. In that scenario, we are using these type of interfaces, Ethernet as well and fast Ethernet as well. Then guys, gigabit Ethernet is providing 1 Gbps bandwidth, the most common standard today, offering high speed connection for most network needs. So that's why most of the time you will see this cable only in the production network as in the big enterprise company. Done. Then for data centers we have 40 gigabit and 10 gigabit. So 10 gigabit Ethernet used in data center and high performance computing environment where very high data transfer rates are required, where very high speed of data rates are required. Then guys, we have 40 gigabit Ethernet, 40 giga. It's also used in data center and enterprises network. So you are going to learn enterprises network, right? Data center. So these two are important for you. But while doing lab in packet tracer or in GNS3 or in EVNG, we are going to use what? Fast Ethernet. Because we will have only fast Ethernet option there. So we will configure OSPF on fast Ethernet, but we will assume like we are doing it on gig 10. Because command is same, configuration is same, everything is same. Nothing is different, right? The difference is only you are doing it now on fast Ethernet. In the real time you will configure it on 10 gig or 1 gig maybe, or you can see the fast Ethernet as well. Now Ethernet cable, these are what the category of, you cannot, we can say the type of Ethernet, category of Ethernet. We categorized Ethernet cables into various part on the basis of speed and capability, on the basis of speed only, you can say, right? Because we have the difference in term of speed only between these all guys, otherwise these all are same. Otherwise there is no difference between fast Ethernet or gigabit Ethernet, or between gigabit Ethernet and 10 gigabit Ethernet, or between 10 gigabit Ethernet and 40 gigabit Ethernet. No difference, all are exactly same, right? So difference is in term of speed only. That's it. Clear? Now Ethernet cable. Here is the type of cable. See, we have multiple types of Ethernet cable. Cat 5 category 5 supports up to 100 Mbps and suitable for home network, basic home network. Okay, so in the enterprises again we are not using cat 5. Cat 5e enhanced cat 5 category 5 supports up to 1 Gbps, commonly used in home and small offices. Cat 6 category 6 support up to 10 Gbps. So which cable you are using generally? This one, right? And this one. So which type of category you will be using? 6 or maybe 6A. Okay, so we have these categories guys of Ethernet. Then how Ethernet work? So yesterday we seen switching, right guys? How switch build MAC address table. So see, as I told you, without address you cannot send letter to your friend or you to your family member, correct? Address is required. Source address, destination address both required, correct guys? So that's why to forward data from one device to another device, we need to add addresses. First we need to add addresses. So that's why see data is broken into packet for the transmission, and packet means what? The difference between data and packet is packet means data plus address, and data means only data without address. So with the actual data we are going to add address, and after that we are going to call it packet. So for the transmission you have to make data first packet. Getting my point? For the transmission you have to make the data first packet, means you have to add the source, destination, source MAC, destination MAC, source IP, destination IP, and that particular thing is called header, where you are going to add it in header. So each packet contain a header with the source and destination address and actual data. So this is first thing how Ethernet work. Data is broken into packet for transmission, and each packet contain a header with the source and destination address and actual data. So packet means my actual data plus source MAC and destination MAC plus source IP and destination IP. This is what guys? Packet. And this is what guys? Data. Hope it is clear. Correct? Header. So this is what? This is header. This is like envelope of your letter. Okay. So Ethernet is responsible to add which header? Ethernet header. Ethernet header. So let's say I am running command ping on PC. So as I told you guys yesterday, that ping is utility which uses ICMP protocol to check connectivity. So once I will type ping 10.1.1.1, my device on my device ICMP protocol will generate one packet. And what is the responsibility of Ethernet protocol there? Adding source MAC and destination MAC, right? So it will add one header, and in the header it will add source MAC plus destination MAC. If destination MAC is not available in the ARP table, then it is going to call ARP protocol. Yes or no? So actually Ethernet is the responsible to add source MAC and destination MAC. So that's why we are saying Ethernet is most popular technology for LAN communication nowadays. Because LAN communication means forwarding data on the basis of MAC address. Who is adding MAC address and removing MAC address with actual data? Ethernet only. Getting my point? Then guys, NIC card. So it will add the header with data. After that it is going to forward it from NIC. So each device on the network has a NIC which connects the Ethernet cable and allow the device to communicate with network. So as I told you, to connect any networking devices to network, you need NIC port, right? And NIC port will have what address, guys? Source MAC address, source IP address. Okay, then switch and router. So switch connects multiple devices with network, directing data packet to their correct destination. Router connect different networks such as home network to internet. Cables and port. Ethernet cables connect devices to switch, router and each other directly. So even you can connect to computer directly together, guys, through Ethernet cable, or you can connect lots of computer with one switch, or even you can connect to switch together, or you can connect switch to router, or you can connect multiple router together, right? Everywhere you can use Ethernet cable, right? And how Ethernet is going to make communication possible between router 1 and router 2? Tell me, guys. With the help of Ethernet header, because this interface here we have one NIC. This NIC will have what? MAC address. On this NIC also I will have MAC address 0B. So whenever router will generate data, Ethernet is going to add source MAC 0A, destination MAC 0B. Then it will forward it from here. Getting my point? In the same way, if two PCA MAC address A, PCB MAC address B. If PCA want to send some data to PCB, PC will generate data and Ethernet is going to add source MAC and destination MAC. Right? Clear, guys? So what should be your definition if interviewer will ask you what is Ethernet? Ethernet is a fundamental technology for modern networking, enabling fast and reliable communication between devices in home, offices, data center, and industrial setting. With various type of Ethernet and corresponding cables, it categorized to different needs for basic internet browsing to high speed data center operation. But guys, think before Ethernet, how I was connecting devices together. Do you want to see before Ethernet? Nowadays we have Ethernet. How I was connecting devices before Ethernet? Means in 1970. Before Ethernet, guys, we had coaxial cable. Coaxial cable, twisted pair coaxial cable. Many times you heard these types of cable, right? So again, we had two types of coaxial cable. One is thicknet 10 base 5, which was providing 10 Mbps speed. Nowadays, Ethernet is providing, guys, 40 Gbps speed, right? 40 Gbps. Just think. So that's why these cable we are not using nowadays, because you can see only 10 Mbps and distance is also 500 meter. Distance is 500 meter more than Ethernet. Then 10 base 2, 185 meters for the shorter range, and speed is again you can see 10 Mbps only. Twin axial cable. So this was the cable. Token ring, very popular technology, very popular. Token ring was the very popular technology for LAN communication, guys, before Ethernet. So shielded twisted pair cable used in IBM token ring network, which were a competitor of Ethernet in 9080. 9080. In the 9080, token ring was the competitor of Ethernet. Competitor to Ethernet in 9080 and early 1990. Token ring used a ring technology and token passing protocol for network communication. After that, guys, we had telephone lines as well. So we were using that cable also to connect devices together. Okay. So leave, you don't need to learn those all. So now tell me, if you have two computer, guys, can you make a network over here? Can you make network of these two computer? Making network means you need to choose the correct cable, right? Correct speed according to your requirement. Not like connecting any cable and configuring IP. According to your requirement, here you can't configure IP address even. So do you have knowledge of connectivity right now or not, guys? Correct knowledge of connectivity. If you can do one thing, you can search these all on Google as well, guys, to learn more about it. But make sure after 2 months it will be very clear to you that if you need to connect to computer, I will tell you the requirement and you will suggest me the best cable according to the requirement, because cost cutting is also very important, right? Like I am going to send very less data between these devices and you are telling me to purchase 40 Gbps cable. This is not true, right? Like this you cannot grow your professional life, brother. To grow your professional life you have to work hard, you have to understand the need of company, requirement of company, how you can provide better service in less money. This is network engineer, because anyone can configure router because commands are available on Google. Only we need to copy it and configure it. But you need to understand the requirement, guys. According to that you need to design network and then you need to configure it. Again, in the configuration part, when we will learn the routing protocol, I will teach you guys. You are not going to learn OSPF anywhere. It's totally depends on scenario. Totally depends on scenario. Where you are going to use OSPF, where you are going to use BGP. So you are learning multiple routing protocol which are responsible for same task. So don't think that I am learning multiple and I am going to use single. No, you are going to use all. Okay. So here, which type of cable I can use? Anyone? I can use even Ethernet as well. I can use the fast Ethernet as well. I can use the 1 gig as well. And now, guys, yeah, now I have multiple computers. So I can connect them together directly. I need a centralized device. Which device you will purchase? You will purchase switch. Why you will not purchase hub? Because definitely you are working in enterprises company, right? And in the company we are not using hub. Let's say you are working in a small shop, like on a center of Patanjali. So that time brother you have to suggest hub. Okay. And which type of cable you will use? Ethernet. And Ethernet, again you have multiple cable na. Yeah, 10 is fine. 1 gig is also fine, right? But switch to, and here again I have lots of computer. Now here which type of cable you should use? More than this or same? More than bandwidth is required here, right? So if here bandwidth is 1 gig, then here bandwidth should be 10 gig, right? And let's say this is connected with router, then this link, guys, this link should be 40, because like this router is connected with many other networks as well. Maybe this interface is virtually divide. One is this one and same network is running here as well, this side also. We'll see these all configuration, don't worry. We can divide this physical interface into virtual interface to connect two different network together, because by default we can configure only one network on one interface. But we can even run multiple network on this interface, on this single interface. Virtually I can connect multiple 100 number of network together through a single interface of router, don't worry. So hope, yeah. Hmm. Where? Between switch and router? Yes, you can. Fiber cable, and then guys internet to router. Earlier we were one more cable, that was serial cable, right? That was also very famous, guys. Serial cable was used to connect point to point devices, like one device to another. Point to point means connecting two computer together or connecting two router together, like this. So serial cable is point to point cable. Here I can use optical fiber cable. Okay, now let's move Ethernet. Hope Ethernet is clear. Any question guys in Ethernet? No, tell me all please. Hmm? Yeah, now again we divide these all in some part. Like now we have suppose one Ethernet cable. This is Ethernet cable, right? Under this Ethernet cable, guys, we have lots of pins. 8 pins are there, means 8 wire are there, very thin wire. Now how you are going to connect connector over here on both end? On the basis of that we have divided the Ethernet cable. Getting my point? How I am going to connect connector? Sorry brother, very good, thank you. Straight through. Yes, Ethernet cable. We divide Ethernet cables type on the basis of how the wire are arranged inside connector at each end of the cable. Clear? Now how we are going to connect wire? So we have first type of cable is straight through cable. Straight through was crossover. Rollover is used to take console access, means to access the devices. Don't worry about the console cable for now. Just suppose we have two types of cable, straight through and crossover. And straight through is what guys? Also known as patch cable. Patch cable means straight through cable. It is a type of Ethernet cable. The wiring configuration at both end of the cable is identical. Identical. Identical means same, which means wires are in the same order on both connector. This type of cable is typically used to connect different types of devices. Okay, so let's say this is RJ45 connector, guys, and I have 8 pin over here: pin 1, pin 2, pin 3, pin 4, pin 5, pin 6, pin 7, pin 8. In the same way, this side also I have RJ45 connector, and I have, sorry, 8 pins. 1, 2, 3, 4, 5, 6, 7, 8. So in the straight through cable, each pins are directly connected with each other. Got it? Like this. Okay guys. This is which type of cable? A straight through cable. If connection is like this, means each wire is directly connected with each other. That means it is a straight through cable. So if you need to make a straight through cable, how you will make, brother? You will purchase Ethernet cable from the market. You will purchase connector, RJ45 connector, and then you are going to insert the pin, right? In this order. Like here also I will put wire number 1 in pin number 1. Then this side also I will put same wire in same pin. That type of cable is a straight through cable. To different devices means switch to router, router to firewall, switch to PC, not router to router, or not switch to switch, or not PC to PC. It is used to connect different types of devices. So connecting a computer to switch or hub, connecting a computer to router, connecting a switch to router. Clear? Yeah, color code is also there. Let me show you color coding as well. If there is no color coding, brother, how you will get to know which wire is the first wire, which wire is the second wire? Yes or no? So color coding is required. So before discussing, okay, wait, brother, let me discuss this point. Wiring extender first, then we will talk about the color coding. Okay. So wiring extender of straight through is, see, in front of you. Color coding is also there. There are there are two wiring extender for a straight through cable. This one and this one. For a straight through cable, both end use same standard, right? Either you can use this one or this one, but most common use is this one, B. And color coding, you can see pin number 1, orange or white. Then if this is white, then here orange. Then guys, sorry, orange white, then orange, full orange, then green white, then blue white, then green. This is color coding. If you want to see, you can simply search it in Google. It will show you how it looks like. Like this. Okay. And how you will make cable? See. And after that, you can see, you can insert it in switch port, or you can insert it in your LAN port, in your LAN port of PC laptop. Yes or no? So are you able to see the color of each wire? By the way, you are going below CCN CCNA, I think. Okay, is it clear, guys? Let me send this image as well. Done, bro. Anything else? Color coding is clear? Yeah. Between straight through and crossover. In the straight through, see, again you have two RJ45 connector. Pin number 1, 2, 3, 4, 5, 6, 7, 8. and this side connector. Again you have 8 8 pin. Pin 1, pin 2, pin 3, pin 4, pin 5, pin 6, pin 7, pin 8. See, in the crossover, pin 1 will be connected with pin number 8. Pin 2 will be connected with pin number 7. Pin 6 will be connected with 6. Like this, all pins are connected in crossover cable. That's why we are saying it is crossover, which is used to connect same type of devices. Means PC to PC. Now you tell me, if I need to connect two PC together, which type of cable I will use? Crossover cable, right? I need to connect PC to switch, which type of cable I will use? Hmm? A straight through cable. Different type of devices straight through, right? I need to connect this switch to router, which type of cable? A straight through cable. Okay. And color coding of crossover is this one here, you can see. By the way, I will share these notes as well, brother. So you will have already color coding at these things. Okay. Clear? Or anything else do you want to teach here, learn here, or teach me here? Anything else regarding Ethernet? Hmm? Anything, guys? Yeah. Question can be, what if distance is more than 100 meter? Because see, the standard after crossover cable, distance and speed. So maximum speed is, guys, 100 meter only. Yes or no? Cat 5 is also going to provide you 100-meter distance, 655 meters, 100 meter, Cat 700 meter, Cat 830 meter. So what if distance is more than 100 meter? Which type of cable you will use? Now let's suppose scenario is this. Here is switch, lots of devices are there, and guys, my router is around 500 meter away here. Which type of cable you will use? Ethernet? Can you use Ethernet or not? Tell me this. 500-meter away. Can I? How? How can? How I can use it? Ethernet cable? Because distance in the Ethernet, in the each type of Ethernet cable is, you can see, less than 100 or up to 100 only. If distance is more than 100 meters, then you cannot use Ethernet cable. What I can do? I can place 5 switches between these two devices, then I can connect it through Ethernet cable. Yes or no? I can place 5 switch. Is it practical, guys? I can, but this is not practical. But guys, you have different types of connector, right? Signal converter. Through that, those devices, you can connect these two devices together through Ethernet cable as well. But you will get latency, correct? You will get delay run. So see, in the production network, where distance exceeds 100 meter, different technologies and solutions are typically used to extend network connectivity beyond the standard Ethernet cable limit. Some common method are, first one is fiber cable, best option. Best option, and most of the time you will use fiber optics cable only. Again, we have two types of fiber optics cable, single mode and multi mode. What is the difference? Single mode and multi mode. Single mode is for long distance means 50 kilometer, 100 kilometer, and multimode is for short distance like 500 meter or 1 kilometer, like this. Clear? So types single mode and double mode. Distance in single mode can support distance up to several kilometers, tends to hundreds of kilometers in single mode. So if distance is only 500 meter, which type of cable you will use? Single mode or multi-mode optical fiber? Multi-mode, correct? Multi-mode typically used for shorter distance up to 500 meter for higher speed, and up to 2 kilometer for lower speeds. For 500 meters, you can see you will get what a speed? 10 Gbps. Wow. Then use case, guys. Backbone connection, long distance link between building. Let's say you need to connect two building together, and same thing you will do in the network, like you can assume the network of a college where we have multiple buildings. So in each building you will have LAN, local area network. You will have lots of devices, lots of switches in computer lab in each building, or maybe at each floor. In the computer lab again there will be lots of computer servers, and there will be a separate server room. So at each layer, each building, you will have what? Switches. Lots of distribution layer switches and one core layer switch. So how you are going to connect these all core layer switches together? With the help of optical fiber. Which optical fiber? Which type of optical fiber? Multi-mode optical fiber. Right? So after Ethernet, yeah. No, through not RJ45. We will talk different connector for optical fiber, right? The LC connector, SC connector, these connectors are used to connect optical fiber. And to connect optical fiber to switch or router, you need SFP. Okay, so okay, leave it for now. Next cable is after Ethernet. Which cable I am using? Optical fiber. We have two types of optical fiber: single mode, multi mode. Single mode is for long distance, multi mode is for average distance. Real time example can be when we are connecting multiple buildings together, when we are connecting backbone connection in the data center, or for high speed network. Then second option is, guys, this is the best option, first one, but still we need to discuss another option as well, right? Because optical fiber is costly. Optical fiber is costly. So Ethernet repeater and hub, you can use what? Hub here, right? So after every, let's say, 80 meter, you are connecting one hub. So let's say you have one switch here and another switch is here, and distance between switch 1 and switch 2 is, guys, let's say what? 150 meters. So can I connect these two switches together without optical fiber? Yes. Yes or no? I can use one Ethernet repeater over here. Done? Clear? Clear, guys? So repeat the signal to extend the range of Ethernet network. Limitation क्या है? What is limitation? Not used in modern network due to collision domain issue. When you will learn collision domain, then you will get what is collision domain issue. But keep in mind why we are not using it. What is the limitation of repeater? Because we have collision issue. Now you don't know what is collision and where collision is going to be occur, in router, in switch, or in hub, where. So we will have lots of collision issue if I will use hub here or I will use repeater over here. So that's why advent of more efficient technology like switches. You can use switch, but it is going to be cost you. Then fiber is best. Then guys, network switch, as I told you, you can use switch as well. After 100 meter, you can place one switch. So these are the option. Next option can be wireless bridge as well. Like let's suppose you have one building over here and one building is here, and between these two building there is road, guys. Let's say railway, this is railway track, and we need to design network over here. So how you are going to connect these two building together this time? You can't place wire here, so you will connect through wirelessly by installing antenna on both building. So wireless bridge is also one device that we can use to connect wirelessly. So use wireless technology to connect two separate network segment. Distance can support distance from few meters to several kilometer, right? So if distance is 1 kilometer, then also you can use wireless bridge depending on the equipment and environmental condition. If weather is bad, definitely you will get low performance, low delay, latency. If weather is good, then you will get good speed, right? So for wireless, this one disadvantage of wireless network is this only depends on environmental factor, right? Condition, environmental condition. If environment is good, then we will get good speed. If environment is bad, we will get bad speed, right? Maybe sometime you will get loss of connection, but still we have option after ethernet, correct? So I have one ethernet cable, I have one another technology that I can use repeater or switch also, right, to extend LAN local area network. Then guys, I have optical fiber that is best if distance is more than 100 meter. Then I have wireless bridge to connect two segments together wirelessly. So connecting two building on a campus across streets where running cable is impractical, where you can use this method also, this device also. Then you have one more device that is media controller. Sorry, I'm saying controller, converters, right? So this converter will do what? Convert copper ethernet signal to optical fiber and vice versa. So if you will use this device, it is going to convert your electrical signal into optical signal, and again at the receiver side you can use same device, you will use same device, so it will convert your optical signal into electrical signal. Let's suppose here I have one switch, right, and here I have one another switch 1, switch 2. Distance is more than 100 meter, right, or distance is let's say 2 kilometer. So I cannot use a repeater over here or ethernet switch or hub. Even I don't want to use wireless bridge, because as I told you, in the wireless bridge case, disadvantage is it depends on environmental condition. So that's why I want to connect it together physically. So I have one option that is media converter. So let's say I am able to forward my data through ethernet cable till here. So what I will do here, I will add one media converter MC, and after that I will connect it to switch number 2 through fiber cable. So this media converter will do what? Whenever it will receive ethernet traffic over here, ethernet signal, it is going to convert it into optical signal, and when it will receive optical signal on this interface, it is going to convert it into electrical signal, and then it will forward to switch 1, right? So it is good for long range ethernet. right? Extend the network reach by converting to fiber for long distance run and then back to as a copper needed. Okay. Technology uses existing copper wiring to extend Ethernet beyond the standard 100-meter. Distance can reach up to 5 kilometer using specialized equipments. Useful in building with existing copper wiring such as telephone line. Not important. You can ignore it. But just now you have this knowledge at least that media there is one device called media converters. Through that I can convert electrical signal into optical signal and optical signal into electrical signal. That's it. Then example of use. So as I told you, optical fiber backbone scenario connecting multiple building in corporate campus, deploy single mode fiber to connect the main data center to various building, ensuring high speed and long distance connectivity. Fine. You have multiple building and all buildings are connected with data center. So you will use optical fiber, and which type of optical fiber? Single mode. If distance is less, then you will use multi-mode. Then wireless bridge for remote location. A company needs to connect an office building to warehouse that is 1 kilometer away. So see, in the city guys, again, in the city, implementing cable is complicated, right? So to connect my network to warehouse which is 1 kilometer away, I can use what? Wireless bridge. So in real time we are using this also, we are using this also. Then guys, switch, this also means to extend network I am using switch as well. So these are real time use case. Connecting multiple building to a data center, we are using optical fiber, single mode optical fiber, or to connect building together I can use multi-mode cable, and to connect all building to data center I can use single mode, right? Then wireless bridge also clear. Switch for network. Okay, this is not much practical I think. Then here you can see the speed. Single mode fiber is going to provide you up to 100 kilometer distance, right? So it is very long, yes or no? 100 kilometer guys. Multi-mode fiber up to 2 kilometers. Please read it. One second, brother. Yes, PoE. PoE extension is also one device to extend local area network. PoE means what? Power over Ethernet. Let's say you need to install AP, access point on a floor. So you need what? Guys, electric adapter everywhere, right? So that you can provide power to your AP. But we have option, PoE option, that we can provide power to light devices from the Ethernet cable. Through Ethernet cable also we can provide power to the light devices like AP. If I have AP, light AP, right, who need very less power, so you don't need to provide electric power there. You can provide power from switch, like you will connect your AP to switch to forward data, but from the same link you can provide power as well to AP. So there are two types of switch port. One is POP and one is non-POP. If port is POP, that means that port have capability to transmit electric power as well. If port is non-POE, that means port cannot provide the power. Port can only provide data. Right. Then guys, rollover cable. Rollover cable is used for management purpose. Management purpose means to access the device, like router. How you will access the router? Through rollover cable. Connecting a computer to console port of router or switch for configuration. So whenever you will configure the devices physically guys, you will use crossover cable. If I will talk about the wiring in crossover cable, so you can see reverse all 8 pins. So pin 1 on one end connects to pin 8 on other end, like crossover cable. Pin 2, 7, and so on. Okay. Then guys, see the connector. To connect optical fiber on link, you need these type of connector. LC connector, SC connector, ST connector. This is what? SFP. So here you can, okay, here you can insert fiber cable. Why we have two port guys? Why I have two port here? One for TX, one for RX. One is RX and one is TX. Means transmission and receiver. One port is responsible to transmit data, one port is responsible to receive the data. And here you can put which type of cable connector? LC connector, let's say. So see how LC connector look likes. This is what? SC connector. Clear? So just you need to remove this and you can insert it in SFP, and after that you can insert the SFP in router. Done. Any question? So now guys, next thing, now you understood about some basic networking devices, you understood how we can connect that devices together. Now we are going to understand how we can address them. Done? Hmm? What will be connected like means? Let's say here I have one device and here I have one device. This is sender, let's say this is receiver, right? And there is fiber cable. This port is TX, this port is RX. right? So this port should be what on this switch? Definitely RX. Then only sender will send from this wire, so receiver will receive it over here, right? So this should be what TX. No, no, brother, I'm not getting your question. How you will connect it to? Brother, here it's mentioned, see both side. Somewhere you can see the TX RX at as well. Maybe behind the opposite side. Yes, you need to insert this. You need to insert this in SFP. Cost of this cable is 2000, you can say. How long it is? Only 20 meter. So that's why I'm saying fiber cable is costly as well, guys. So this is not sure that every time you are going to use optical fiber only. Maybe you will use wireless device. Maybe you are using media converter. Maybe you are using Ethernet repeater. Okay, in the fiber, actually, in the fiber cable, we will get lots of speed, good speed. Why? Because, guys, it works on total internal reflection. You know total internal, anyone know total internal reflection? Means your traffic is going to move with the speed of light, because your traffic is going to move in the form of light. So SFP will convert electrical data into optical data, and if data is not optical, then I can forward it with the speed of light, and light speed is 3 multiplied by 10 raised to power 8, 3 multiplied by 10 raised to power 8 meter per second, I think, right? So with the speed of this, your data can travel from one end to another end. So yes, tell me which type of cable I will use here, guys. See, I have multiple types of cable here. This is my, which type of cable it is? See the name here in the bottom, guys. Name is showing. Oh, not showing. See here. So now tell me which type of cable this is. Console cable. Console cable is rollover cable. So it is used to access the device, right? Then guys, which type of cable this one? Straight through. Then crossover. Then fiber. Phone. Leave, these are coaxial, serial, leave it. USB. So here to connect PC and computer, which type of cable is required? Fiber. Serial. Ethernet. So which type of Ethernet? Straight through or crossover? Straight through. So I will select a straight through cable here like this, and then I can connect that together. See how many ports I have on this switch. 24 fast Ethernet port and 2 gig interface port. Why we have gig interface port, guys? To connect switches. So here I am going to use, let's say, fast Ethernet. 0/2 is connected with PC2. 0/3 is connected with PC2. 0/4 is connected with PC3. Done. But the good thing is here nowadays devices are automatically device can automatically sense the cable. So you can see you have one automatic option here. See the name of this cable, guys. Automatic choose connection type. So if you will choose this cable, your device is going to automatically detect the cable. So if straight through is required, then it will automatically connect straight through. If crossover is required, then it is going to connect crossover. Now guys, let's say here I have one another switch. So which type of cable I will use to connect switch 1 and switch 2? Again, let's say here I have some PCs. Straight through, straight through. To connect these two switches together, which, yes. Which type of cable is required? First of all, tell me the cable, na? Crossover or straight through? To connect these two switches together. Crossover. So let me select the crossover and let me connect it from, let's say, G1, G1, like this, right? But distance should be only 1 meter, up to 1 meter. Distance between these switches should be up to 100 meter. Now I have one another switch here. So you tell me now which type of cable I will use, crossover or straight through to connect other switches. Crossover. And which port? Let's say Giga 2. And see, if I will use the automatic cable, then also I can connect it. But it have connect to fast Ethernet port, right? It has connected to fast Ethernet port. So let me connect it and let me connect the manually G0/1 to G0/2. So is connectivity fine? Yes, connectivity is fine. Now I have one router here. Hmm? Which type of cable? Straight through or crossover? Straight through. Okay. Let me connect it 0/0. Which port? Which port? Fast Ethernet? No. So brother, see, in this topology, one link is backup link. Between switches, this link is my backup link. Yes or no? Because this port is in blocking state. Correct? So switches are not going to use this link to forward data. Yeah, definitely switch will use this link, but when any link will goes down, any link, if any link will goes down, then only switch will use this link. So here I am going to place what? Fast Ethernet, and here I am going to connect what? Giga Ethernet. Okay. Getting my point, what I am guys trying to teach you. So according to the requirement, you should connect the devices. Yes or no? So yeah, I'm going to remove the Giga and I am going to connect what? Fast Ethernet. So fast Ethernet 0/1. But is there any benefit of doing this? No, because router don't has giga interface. Router interface is by default disabled. You can see switches interfaces are up, right? But router interface is down. So yeah, I'm going to replace the router as well because I need guys 1 Gbps bandwidth, but this router don't have capability, right? This router don't have gig port. This router have only fast Ethernet port. So what I can do, I don't have any other option. Simply I have to replace the device. So I will delete this router and I will use any latest router. Which type of cable? Crossover or straight through? Now we have gigaport. Now connection is good. Yes or no? Because on that router gig interface was not available, na? It not showing. Only fast Ethernet port was there, na brother? That's why. That's any question? Not why you guys are not asking question, by the way. Okay. So we understood the connectivity as well. Now we need to understand what, guys? Addressing. How we will do the addressing over here. Okay. So next class, types of address. MAC address and first MAC address, then IP address. One difference is this one is 48 bits address and this one is 32 bits address. Okay. Now tomorrow you tell me the 5 difference between MAC address and IP address. Okay. Yeah. Yeah, actually, line protocol of this interface is down. Router interface is down. That's why it's showing you this interface down. By default, by the way, this interface is up. This interface is up. You don't need to configure this interface. But it's showing you down because their connected device interface port is down. Right? So once I will run no set command on router interface, automatically switch port will also come up. Right? If you want to see, simply I can access this router, say no here, enable config t, and then go to interface g0/0 and say no set. See, done. So actually devices since never port is up or not. Like on the router, you can see if you will run command show IP interface brief. So you can see fast Ethernet 0/0. Port is down or up. And their line protocol is also up. Line protocol means what? Means switch port. Port of switch which is connected with router. Status, status means my port. And protocol means my remote device port. Yes, means switch G0/0. So even switch G0/0 port is down, then also guys router will not forward traffic from this port. Is there any logic to forwarding traffic from 0/0 from router if switch port is down? Right? So if this port is down then router will down line protocol port. And if line protocol is down, then router is not going to forward any traffic from that interface. So every device is maintain this. Every device trace line protocol. Like guys, on switch you can see on this switch. Means remote device, like see line protocol of 0/0/1 on this switch means what? Port of PC0. Line protocol of 0/0 means I am talking about this port. If line protocol of this port is down, guys, that means what? This interface is down. This interface is down. If this interface is down, then their status will be down. Yes or no? Oh, okay. See, if this port is down, then status is going to be down. If this port is up, but PC port is down, then line protocol is going to be down. But status is still up. Got it? Right? Like on switch, you can say so interface, so IP interface brief. So see line protocol of 0/1 port is up, right? Because PC port is also up, and 0/1 this port is also up. But see guys, 0/4 5 port which is not in use, line protocol as well as status both down, right? See switch, this switch is connected with switch 2 with which port? 02. So IP interface brief G0/0 line protocol up, status up. So if I will down this interface on switch number 2, if I will down this interface on switch number 2, what will happen on this switch? This port will be up, but line protocol will be down, right? Like on switch number 2, go to interface G0/2 and say shutdown, right? Now go to this switch and see show IP interface brief. G0/1 status is, oh sorry, 0/2 status is line protocol is down, right? Even here on 0/1, sorry, 0/2, I can say no shutdown. So IP interface brief. You can see still 0/2 down. No, line protocol is down. That's why it is showing you their on interface as down. But this will not happen on router. See, on the router, which interface is connected with switch? Z0/0, line protocol up, status is also up, correct? But if I will down switch interface G0/1 and say shutdown. Now go to router. See, status is up, but protocol is what? Down. That means my interface is up, but switch interface which is connected with me is down, right? मतलब हाँ दिखते हैं ना, नहीं स्टेटस अगर डाउन है तब तो लाइन प्रोटोकॉल भी डाउन ही रहेगा, राइट? लाइन प्रोटोकॉल इसलिए है ताकि हम डेटा भेजने से पहले ये चेक कर सके कि मेरा जो नेबर डिवाइस है उसका पोर्ट अप है या नहीं है। अगर उसका पोर्ट अप नहीं है तो फिर डेटा भेजने का भी कोई लॉजिक नहीं है, अननेसेसरी क्यों बैंडविड्थ यूज करूं इसका, ऐसा। Got it? Correct. So in the troubleshooting, let's suppose between router and switch there is no connectivity. So from the router number 1, what I can check? Line protocol of this switch. Is line protocol of this switch is up or not? Because it should be up. Done. You have two router R1, R2, 0/0, 0/0. Say this port is up, this port is down. Tell me status will be what here? Status will be up, na bro, because this port is up. Administratively this port is up, but their line protocol is down, so line protocol is going to be down. On switch router number 2, status is going to be what? Down, and line protocol is also going to be what? Down. Clear?